utility operations. We're transforming utility operations with digital twins, lean workflows, and AI. My name is Christian Schroeder with WDI, and I appreciate you taking the time to join us this morning. This session brings together 4 organizations, WDI, LINQ, Fulcrum, and Marquee Insights, each working in different parts of the utility ecosystem. The goal today is not to present a single product or one-size-fits-all solution. The goal is to look at real challenges across utilities and large organizations and what they face, sharing practical examples and demonstrating tools and approaches that can help strengthen operations in ways that are adaptable, measurable, and realistic. Most utilities in this room today are navigating a familiar landscape. Processes built during earlier phases of modernization now carry significant heavier workloads. Systems that were never designed to work together side by side. The teams bridging gaps with Excel sheets, email threads, or paper forms that require manual reconciliation. In many cases, the glue holding everything together is institutional memory, knowledge that could be stored in people's heads rather than systems. And none of these issues reflect failure. They reflect the pace at which operational demands have changed. The webinar that we're sharing today is designed to speak directly to that reality. And we've structured today's content around concrete examples rather than abstract frameworks, with the intention of showing what's possible where organizations have found traction and what approaches can support operational clarity and efficiency. You're going to see several themes carried out through the session today. First presentation is around lean methodology. Lean is often associated with things like manufacturing, but at its core, it's simply a structured way to understand where work slows down, where effort's duplicated, and where teams absorb friction that can be removed. We're going to be looking at examples of how utilities can leverage lean to see their processes more clearly and identify changes that reduce strain on both field and office teams. So I will be presenting that with Gunnar Gardenhire today. And then second, we've got digital twins through LINQ. So most organizations talk about modeling or simulation at a conceptual level. What we're going to be showing today with Neil Calvert is more tactical. LINQ allows teams to model how information actually flows through the organization across people, systems, before investing in changes. So it provides a way to evaluate options, understand impact, and build alignment early. Third, I'm going to be coming back to share practical use cases focused around public safety shutoffs. So you'll hear PAS a lot today and emergency operations. The aim is to illustrate how operational visibility and structured workflows, real-time data can support better coordination during time-sensitive events. And then fourth, with Trip Gott, we're going to be doing document management and AI-supported training. So many utilities still rely on manually updated documents, shared drives, email attachments. We'll show how structured document management and AI-assisted training workflows can help reduce onboarding time, improve consistency, and reduce the effort required to keep teams aligned. And then last but not least is around mobile data collection. So Jake Freebald with Fulcrum is going to be sharing how across the industry, field data remains one of the most inconsistent pain points. Paper, Excel, disconnected apps create delays, errors, and re-entry work. So we're going to be walking through examples of how mobile tools are being used to simplify field operations, eliminate bottlenecks, and provide operation teams with same-day visibility into conditions on the ground. So throughout the session, the focus stays on practicality, what actually works, what produces measurable improvements, and how these methods can be applied without forcing a complete overhaul of existing systems. You're going to see a mix of concepts and demonstrations and real examples today that help you think about how these approaches could fit within your organization. We're going to be running live polls today to collect your perspective as we move through each segment. We're going to be prioritizing those giveaways based on your poll engagements at the very end of the webinar today. You can submit questions at any time, and we'll close with an open Q&A roundtable discussion at the end, wrapping up at 9:45. So let's get started with today's presentation. What we're going to be focused on today, though, is talking through the value stream analysis. And we're going to be talking through real world examples of using a tool similar to this to impact a process or a procedure. So as you can see in the flow diagram, the waste is automatically tracked. We're going to be talking today after this presentation with the LINQ tool, where most of this information can come in from, determine the process efficiency, and which tasks that there might be an opportunity to remove. So with that, I'm going to turn it over to Gunnar, who's going to present a real-world case study using LINQ and using systems like this to achieve measurable savings.
All right, thanks for that, Christian. Hi everyone, I'm Gunnar Gardenhire. I'm the principal consultant with WDI, and the use case I'm going to cover today is a project we did with Xcel Energy on the ADMS deployment. And the ADMS deployment had a lot of criteria around data quality initiatives. And the initial part of the project, it was thought we needed to go out in the field, collect all the attribution to make the ADMS model as good as can be. And through the optimization structure that Christian outlined, what we did is we ended up looking at what we were collecting in the field, what was the impact of those changes on ADMS specifically, and what was the value in that. So as part of that effort, Xcel, Pete Gomez, he was the lead owner of the project there, and us and NREL performed a study on some feeders and looked at what level of attribution and data quality needed to be collected in the field to make all the advanced applications in ADMS work. And the summary of that is what you see on the screen here is we categorize the levels of detail into level 1, level 2, level 3, and level 4 with NREL. And then we modeled it out to see what would be the project savings and what was necessary and not necessary. So I'm going to show you quickly, I'm going to share my screen and show you kind of a little more detail on that. But you see overall the cost savings for Xcel Energy. And this was collecting over 3,000 feeders. Level 1 attribution, if you just collected that from the field, it was a $2.4 million budget. And then added level 2 onto it, added level 3. And then again, if you did level 4, the full-blown inventory. So let me share my screen quickly here. And jump to. Okay, great. So this was kind of the summary of it. There's a full report here on the right that basically walks through exactly how NREL approached the study, outlined all the levels of data quality. And the real question we were asking is what level of data remediation does a utility need for an ADMS deployment to leverage all the advanced applications? So this was the sort of summary of it all. And they basically, like I just mentioned, came up with 4 levels of attribution. So we took this categorization of 4 levels, we analyzed it in the GIS and said, these are the features that we need to go out and collect in the field to meet the model requirements Xcel was looking for. So I'm going to jump ahead. This was broken up between collecting rural feeders, urban feeders, and semi-urban feeders. It was a mix of overhead to underground as well, so we could get a good gauge of the whole project. And through that, then we took that and did the whole analysis in Power BI. So we actually went out to the field and said, okay, let's collect this data in the field. Let's see what changes actually come back and what the results are. So what you're seeing here is analysis of the 18 feeders we used in the test bed case. There were 52 tables, 229 different fields, and there was approximately 35,000 changes. NREL level 2 defined all the attributes that were important for that category that NREL put out, and these are the attributes in here. NREL level 3 added on some more attributes, and basically where we landed at was a combination of, we did 2 and 3 and then a little bit from 4 for the whole process. And then we said which of those attributes have to be collected in the field. So if I select field collection here, you'll see then all the changes that happen. And of course, a lot of the changes for the ADMS were wire size, type, gauging. So it wasn't so much particular about going out and getting pole numbers. It didn't really matter. It was really size, type. And you can see here for size, there was changes among these feeders. A lot of attributes went from blank to a known value. So this was pretty much par for the course for the project. But the key was to take this study put it in a model that we could map the current state of the project, which Neil's going to show you in LINQ, and then map the future state of the project, which would show the projected savings. And the real key to doing this type of work in the modeling LINQ is you analyze the cost savings before you get too far into the project. So you're not doing a post-mortem on the project to figure out why you're behind schedule and over budget. You sort of model it out ahead of time, and you know if you can adjust your project schedule, both budget-wise and duration. And it was quite a good success for us. And Pete Gomez was the lead person for this, and he did a phenomenal job at managing this project. And it's quite a robust model that Excel was able to develop under ADMS. So with that said, I'll pass it off to Neil to kind of talk about the LINQ model and how this is modeled out.
Thanks, Gunnar. Before we transfer over to Neil, we had a poll question. If we can go ahead and get up the first poll question. If just a reminder, participating in the poll, there's a giveaway at the end. We got a couple votes coming in. So which operational challenge is impacting your utility the most right now? And we're seeing quite a few coming in for manual or paper-based process and data quality. We'll give it another 30 seconds. Okay, I'm going to go ahead and end poll. Great. Well, we're going to be talking today later on manual or paper-based process and data quality, sharing a presentation on that. And that looked like something that was of interest to most of the folks on today's call. So with that, I'm going to transfer it over to Neil.
Hey, good morning, everybody. I'm just going to share my screen. Before I jump in and show you the content that we've created in LINQ that relates to the data that Gunnar's just shared with you, I wanted to take some time just to really introduce the idea of a digital twin of the organization, because it may not be something that people are particularly familiar with. So just a quick run through about why we think it's important and where it can impact your organization, maybe differently than the tools that you're using today. So there are four things really that I think about as motivation for trying to do things differently. The first one Christian has already mentioned, which is despite all of our efforts, we're still in a position where 70% of change and transformation projects fail. I also keep thinking about the fact that we're in the digital economy, and yet we don't really have a focus on our data and information inside our organizations. The poll, the top response there was paper-based processes inside our organizations being a challenge. The pace of change is continuing to accelerate, and AI is the current best example of that. You think about how much that technology has changed just in the past 6 months even. And then the tooling that's available for people inside the organization that are trying to help us respond to continuous improvement and change are potentially not contributing the value that they should. So to dig into those just a little bit further, from a failure perspective, we waste $900 billion a year in failed change programs, and failure is a project that does not meet the objectives that were set at the beginning of the project. And just for some context, I'm based in New Zealand. New Zealand's GDP last year was $260 billion. So we're wasting almost 4 times a country's national GDP each year in failure. I think that's a significant amount of money, and I wonder why this number is not changing. The second thing is the content. We have disciplines such as asset management for physical assets inside our organizations, and yet we don't apply necessarily the same rigor to the data and information that we hold, which is actually the lifeblood of our business. And that's despite having principles such as infonomics that we can deploy inside our organization in order to think about the value of the data that we're using. This is a principle that's been around since 2018. So for 7 years, we've had some really robust methodology that we can deploy inside an organization to help us describe the value of our content. And I think when we do this, we get a different perspective on our organization. So that's my second thought point. The third is the speed of decision making. We lose 500,000 days per year in slow decision making. That's an incredible amount of human capital that's being wasted as we effectively sit and do nothing. And yet we know that a fast decision actually corresponds to a high quality decision. And so what is it that we're not doing inside an organization to help our decision making accelerate so that we can do more cycles of change inside our organization and identify these opportunities to mitigate the waste that we inevitably have? And the fourth thing is this tool question. We still see educators producing business analysts primarily that only understand business process modeling notation, and then you have to specialize into other areas to be able to even begin to think about Lean Six Sigma as a methodology that you can deploy. And yet there are other methodologies and tools out there that a business analyst in particular could have access to in order to elevate their utility inside an organization and start providing value to the business. And so I think this is an area that we collectively need to be focusing on in order to have quality decisions being made inside the organization. So all of this means that I don't think this works anymore as a mechanism for understanding your organization and the things that you should be doing to achieve success. I don't think this works anymore because it's too complicated and people don't understand what this notation necessarily means. And that's borne out by the fact that this is the type of content that people typically capture, which doesn't really have any value to the organization. There's no data here. It's a picture, lines and boxes. You cannot make any decision. And a lot of people, even with this simple structure, would struggle to understand what it's trying to convey in terms of process and what the business is doing. And so we believe that there's a requirement to think differently. So LINQ as a platform has been designed to really focus on the data that an organization requires to be successful, to get to the awareness 10 times faster than using other tools and methodologies, to create insights directly inside the platform that enable a decision maker to understand the impact of any potential change, to be able to have a holistic view end-to-end of an organization, which eliminates the opportunity for scope creep to come into projects which then add cost and often end in failure, to make sure that we can have more innovation cycles and that we can do them faster and faster, which means we just get more done, and to have a digital first approach to the content that we require and the analysis that we need to make, and therefore the presentation of the data. So this is what we're setting out to achieve by bringing all of this type of content into a single platform. So our methodology is a fairly standard one, and those of you who operate within the Lean methodology will immediately be familiar with this. We are capturing the current state of how an organization operates. We're delivering insights based on that model. We're then capturing a future state, which is a response to the insights that we find about our current state. So that could include the mitigation of waste that's been identified through process change or organizational restructure or implementation of new technology, whatever the change response needs to be. We understand the impact that change will have on the business. And this is before we have even gone anywhere near implementing anything, setting up a proof of concept. It's still all within the model. Once we understand the impacts at the beginning of a project, we can make a decision as to whether that change is valuable enough to the organization for the investment that needs to be made. We're able to measure the value of that potential change and indeed the change when we keep our models in sync with implementation, and then we start again. So the idea behind LINQ as a platform is we're actually creating a tangible digital asset that the organization has access to in perpetuity, that can be kept in sync with the way that the organization is operating. So we always have a current state that we can refer to when we start to think about change. It's based on a very simple language. So if you think about the BPMN slide that I briefly showed, in contrast, we are looking for the information supply chain, which is the connection between work that is done, actions that take place inside the organization, and the data and information that is created, which then supports the next action to take place. So we're looking for that flow. And then we're looking for the enablers of that supply chain, which are people in roles inside the business and the systems that are used. And a system is not necessarily just a piece of digital technology. The poll suggested there's still lots of paper processes. Paper is a system. So if we begin to understand the tools that people use and the systems that are supplying our information, which then forces us to work in a particular way, and we're able to quantify this model with the frequency of work, the duration of work, the capacity that people have to do work, we put ourselves in a position very, very quickly to get better insight about our organization and then make these important change decisions. So with that kind of scene setting, I'm going to jump into LINQ, and we are going to take a look at the data that responds to the content that Gunnar shared. So this is the organization view. These are models that are connected so that we can actually understand the downstream consequence of the work that we do inside an organization. And we're going to jump into the data feeder collection model. And here you'll see the language that I showed on the slide kind of exposed into the platform. So 4 nodes, information, action, system, people, they're connected together in that structured way. This content is captured typically in a workshop with subject matter experts. And the value of doing that is we can capture process and also activities that happen outside of the process, and capture that content in real time with the subject matter expert and typically the process and outcome owner in order to create a true representation of what the organization does. And then these models become very consumable by other people inside the organization and rapidly easy to understand. So if I quickly kind of show you some of this, you will immediately begin to understand the notation here and start to be able to read this model. And so when we started to analyze the process around data collection, that Gunnar shared the data for, we can see that we're assigning content for field collection, and we've got these NRL level 2, 3, 4 attributes that we need to collect in the field. So here's our action, which is assigned this content for field collection, and we're able to specify the percentage of the different types of data that have to be collected. So out of our 34,000 attributes that or feeders that we're actually collecting data for, we can see the split across level 2, 3, and 4. So we just follow the level 2. You can see here's the field collection taking place. We know the role that is doing that work. Against this field data collector, we have a set of content which lets us understand how many people we have inside the organization and what their capacity to do work is. So that's typically your 7.5 hours a working day for 46 weeks of the year, creates a total number of hours that this role has to be able to perform this action. We can see the output from the field collection. So this is collected data at level 2. So importantly, we need to say that we're creating content that represents real data, real people, real processes that exist inside the organization, but it's abstracted away from the real data. And that just means we can do this very, very quickly. We don't have to worry about connecting to content inside the organization. And if we describe it as people talk about it inside the business, people will understand what this means. So once you've got this data collected in our field data collection app, there's some post-processing that takes place. So we end up with validated data. Now it's inside the GIS. Then the GIS analyst will verify the feeder delivery, and then we end up with verified data inside the GIS system. Each of these actions are the container of the effort. So this geospatial verify level 2 feeder delivery being undertaken by the GIS analyst, this happens 12,240 times each year, and it takes about a minute. So we've got 12,240 minutes associated with the GIS analyst. So now we're extracting the capacity from this role. So as we build this content out, and doing that is super straightforward. The platform lets us just drag and click and label in order to create new content. We can grab systems that we've already captured inside the platform. We can drop roles in. We can basically connect everything up super fast inside the platform. What we end up with is an opportunity to look at the actual data behind the model. So immediately we are seeing the cost in people terms, in system terms. We're seeing the amount of time that is required to deliver our outcome. And our outcome is that we've got this feeder data verified inside the GIS. And so very quickly, just with these 4 simple notations of information action system people inside the business connected in this structured way, we can deliver all of this data, which means we can start to report on it. So we can go and find a role, and we can see how many hours they are spending. So we've got basically 567 hours split across these 4 roles inside the model. But importantly, this model now connects to the next phase. And so we move from collection to QA/QC. So if we jump inside this model, now we can pick up the outputs, which is our verified data in our GIS, and capture the QA/QC process. So here we're doing reviews, and we're submitting data for review. We're doing an initial review. Over on this side, we're doing a slightly different review outside of the GIS system. Again, we're capturing all of the effort that's required. We can trace from here to understand the impacts of the work that we're doing. We can split flows based on how data is QA'd through our process, and capture data about the amount of data that passes our QA/QC versus requires review and therefore rework. And again, we're able to identify the cost that's required. So this is all current state, and it wraps up into insights where we're able to pick multiple pieces of data inside our organization and bring it together to fully understand the total cost of the process. So that data capture, data QA process inside this organization is $750,000 worth of people cost, and we've got nearly 10,000 hours of time that's required a year to be able to do this work. So this relates to the numbers that Gunnar has shown us. So the question is, well, if we don't need to be capturing all of that data at that level, what happens if we model a future state where we are responding to the data that we have found, and we're able to provide an impact assessment to the organization, which corresponds to their budget. So they understand how much money they're saving, and importantly, how many hours they are providing back to roles inside the organization. So current state is just the baseline. And so now we're able to go and look at how do we build a future state. So in order to do this for the organization, we start with our current state. We create a project, which is about the optimization, and we simply create the model that represents how we'd like to work. And in this case, it was taking the level 3 data out of the process. It's not all needed to be collected. And so if we identify that it's a valid approach to reduce the amount of field collection that's required, because we can do this work internally instead, in this case, we remove that element of the work from our model. So we are then able to immediately express the impact that this will have on the organization. So in this case, we're taking about 30% of the total work out of the effort required, and therefore the cost. So here on the dashboard, you can see that in the current state, this process cost $250,000, and we've dropped it to $158,000. We've removed 30% of hours that people have to put into the process, and all of this saving is then able to be reallocated into the organization to do different things with the same resource. And we, as you'd expect, we can report on any of this. So I can pick up roles, I can look at my hours, and I'm able to graphically see the impact that we have on roles inside the organization. We can also go down to the action level, and we can see which actions we've removed from the process, and which should be modified based on different ways of working. And as you'd expect, you can also roll this up into our at the insight level. And so the platform is being designed to allow us to very quickly capture our current state and analyze it, to model away from the current state to respond to the opportunities that we find. Lean Six Sigma becomes a very important methodology to be baked into the platform at that point, because mitigation of waste could be the driver for our change. But importantly, we're expressing the impact that the change will have before we do anything inside the organization. And then we have the scary button inside the platform, which is replace current state. So to keep the data in sync, once we have made the decision that this is something that we are going to actually do inside the organization, that project can spin up. It understands the work that needs to be done. Importantly, it understands the downstream consequence of change. So we're also managing that. We're not just changing something in isolation and hoping that everybody else can pick that change up and continue to operate in the same way, because we can see the impact that it will have. We can move our future state to become our new current state. And now the model is in sync with the way that we're operating. So this is the power of modeling in the platform and the experience that LINQ creates to bring everybody on board, provide a single perspective. It's a visual view, but people can basically get around it in order to be able to fully understand. In order to just kind of show that there's, we're not just talking about single processes inside organizations, and to kind of connect to some of the other content that you're going to see on this presentation. This is a model which looks at the PSPS process. So exactly the same notation. We've got our 4 nodes. All we're doing now is we're articulating, using a different taxonomy, and different roles, the process that would happen if we're managing PSPS. And so LINQ can be applied to many, many things. Here you can see we're capturing weather data. We're using telemetry. We're doing a risk assessment. We're updating a dashboard. Once we get to PSPS being required and we have an escalation alert, then we're moving into the asset management system to understand things that are going to be impacted. We're planning to de-energize the circuit. We're doing monitoring, and then eventually post-event we are working out how we re-energize the circuit. And over here you can see we're doing all of the planning around switching and reporting. And when we have models in the system like this, we've got some additional capabilities that can help. So this is a temporal analysis of our process. So having content like this means that we can start to look at the way that the business operates, and we can start to identify any hotspots in terms of the capacity we have inside the organization and the ability for those people to respond to what's going on. So you can see here, as events are taking place and early in our process, it's all about monitoring. It's about looking at the weather, it's about spotting patterns. But then when events fire that require the PSPS response, you can see where the roles are able to cope with the number of events that take place. And if we want to mitigate incidents like this, where we're having somebody, in this case, manually update an internal dashboard, which is creating a potential queue, then we're able to understand how many people we need to put into this role in order to cope with the volume of work. Or we could use this as a driver for some automation and be able to model that inside the platform. So the utility of the data captured inside LINQ can vary and can extend once you have these models to become somewhat operational and allow you to consider planning for the future. So I just wanted to throw that in as an example of how models extend from just visualizations to actually providing somewhat real-time analysis based on the way of working. So with that, I'm going to hand back to the team. I think there's another poll that we need to run before we continue on with the presentation. So thanks for your time. I'm going to stop sharing and hand it back over. Thank you.